Today's Daily Dose of Math is an example of a task from the Math 4153 geometry course. A task is one of the big questions on the exam where they expect you to go through several steps in order to be able to get to an answer. It's worth more marks. The question is quite long and no diagram is given. I'll read the question. While underwater, a diver swims horizontally from point P1 to P3. About 1/3 of the way there, they stopped briefly at P2. P2 is 100 meters from P3. A few meters directly below P1 is a shipwreck, S1. The angle from P2 to S1 is 50 degrees, and from P3 to S1 is 20 degrees. How far is P1 from P2? Now, the reason I wanted this in a task example video is because usually in this type of course, a diagram is given, but not always. So if you get a task where there's a lot of information given in a paragraph like this, you need to draw a diagram in order to visualize the situation. And I've detected that some of my students struggle to follow the instructions in a paragraph like this, drawing a diagram. So I want those students to practice it. I'm going to start by marking point P1 and point 3 and connecting them with a line. It's a horizontal line. I'll put P3 at one end and P1 at the other end. And this is underwater, so I'll just represent that by showing some waves up here. I'm not going to draw the diver. About 1/3 of the way there, the diver stopped briefly at P2. So just somewhere around 1/3 of the way, I'm marking P2. That's point 2. P2 is 100 meters from P3. So I can draw a label showing 100 meters separating P2 from P3. I have my first distance in this situation. A few meters directly below P1 is a shipwreck S1, so I'm going to put that down here, but I really don't know how far down. It's a few meters, so it could be just 3 or 4 meters. It would be very close. I'm just going to draw it in a way that I can see it. So I'll draw a line straight down from P1. Directly below means straight down, so I have created a right angle, and I'm going to label that the shipwreck S1. The angle from P2 to S1, now that's where students seem to get confused. If they didn't do a good job drawing the instructions up to this point, they end up drawing an angle that really doesn't match the situation very well. So P2 to S1, I'm going to connect them with a straight line, and I'm going to mark that angle, and they say it's 50 degrees. So the way I've drawn this so far, that actually ends up being a reasonable angle for this triangle I've drawn. And then the angle from P3 is 20 degrees, so I need another straight line. And I need to mark this as 20 degrees. I have two triangles. I have three triangles. I have P1, P2, S1. I have P1, P3, S1. And of course, drawing the smaller one inside the larger one, cut the larger one into two triangles. So I also have P2, P3, S1. The first two of those are right triangles. And then P2, P3, S1 is non-right triangle. And that's the only one that I have a side length for. P2, P3 is the 100 meters. So I can see that I'm going to have to use this non-right triangle to answer the question. How far is P1 from P2? I'll put a little X here to remind myself that's what I'm looking for. I'd really like to work with this small right triangle, P1, P2, S1. I have an angle. I have two angles. I have all three angles because I have the 90 because of the direction directly below. That implied a right angle. I have the 50 that they gave me, and I can subtract from 180 to find the missing angle. But having all three angles in the right triangle isn't going to help me to find a side length. I need another side length in this small triangle in order to proceed. And what side does it share with another triangle? P2, S1 is shared between the small right triangle and the non-right triangle, P2, P3, S1. So I want to find this side. How can I do that? I have a side length, I have an angle, and I can figure out more angles. So I see sine law coming up in my future. That is principle 8. First thing I'm going to do is the supplementary rule. Say so, because what I'm going to do is say 180 minus 50 equals 130. And then I can draw that into my diagram. I use supplementary, so I should say so. Otherwise, whoever's correcting this might be saying, well, how do you know that's 130? I'm not going to get full marks in that situation. I also can subtract from 180 because the three angles in a triangle add up to 180. So I'm briefly going to say 3 angles in triangle total 180 degrees to explain what I'm doing next, which is this subtraction. 180 minus the 130 I figured out in the previous step minus the 20 I was given equals 30. I have found this angle, and I mark it on my diagram. Now I can do sine law. I can't do SOHCAHTOA with triangle P2, P3, S1 because it is not a right triangle. I can do sine law, principle 8, so I'm going to say principle 8. I know the 30-degree angle and the opposite side 100 meters. So 100 over sine 30 has to be equal to my unknown S1 P2 side over sine of 20 degrees. I didn't need to use the 130-degree angle in this step, but I needed it to get to this step. Now, isolating my unknown, I'm no longer going to call it P2S1, I'm going to call it x. X is equal to 100 sine 20 over sine of 30. And is equal to 68.4040. It will be in meters. I go to 4 decimal places because I don't want to round too high, because this is not my final step. So rounding too high introduces more error. I avoid error by going to several decimal places. Now what's left? I now know that this is 68.4. On the diagram, I'll just write 68.4 meters for space. And now I have enough information to switch into this small right triangle, P1, P2, S1. And this is going to be a CAH situation. I know the 50-degree angle, I'm looking for its adjacent side, and I now know the hypotenuse, the 68.4. So, cos of 50 degrees equals x over 68.4040. X will end up being equal to 43.9692 meters. And I have finished answering my question. Now, why is this a task? When we look at the question after we're finished, we think, well, that was easy. This is only a few steps. A couple of them are just subtractions. It doesn't really feel like a task once you've successfully solved it. But there was an extra level of difficulty added by not giving the diagram and expecting the student to be able to interpret this situation. A student who correctly interpreted it and made a decent diagram ends up thinking the question was quite easy. But things can go wrong along the way, and it's important for a student whose diagram wasn't made perfectly to fight their way through the process. That's a task. It's important that you get to the end of the question, even if you think you may have made some mistakes along the way. Now, another thing that can happen here that can confuse a student happens right here in the instruction about 1/3 of the way there. That can make the student think of the ratio formula. where a third of the way there implies a ratio of 1 to 2, and then you plug in coordinates from vertices in order to use that formula. But there is a clue here that we don't need that formula, that it doesn't apply, which is simply that we haven't been given any coordinates in any way. So that should make a student who knows what they are doing realize, okay, I'm not using the ratio formula. I'm using trigonometry formulas and geometry principles to answer this question, and that particular formula is not necessary. That is today's Daily Dose of Math. Please like, subscribe, and share.